Hello everybody and welcome to another video. Today we're going to use Blender and Python to make an animation. Um, if you look at the shorts, you can see that they posted some funny animation of Steve in Minecraft and someone else, uh, Pinky from Sprunki. Uh, yeah, doing stuff. And I'll teach you how to make some other animations. Well, I teach you some skills you can use to make animations with characters and stuff, like um, the animation I posted. So first, let's get started. So first thing we need to do is remove this cube over here. So just do that, and yeah, roll right click, delete. Alright, next thing we need is we need to import our characters in. So you can do like whatever you want. Well, actually, I'll teach you how to do the animation with Steve from Minecraft. Then I'll teach you how to add some other characters in. So for Steve, search up Minecraft. Um, this thing, Minecraft BPS character version. So Minecraft is the game, obviously, character version 4.0, and that BPS is an Minecraft animation studio, and they have Steve in it, so we can use theirs. So you just click on some of these to download the BPS. Like I already downloaded it, so I'm not doing it. I'm not doing it in this video, but just download BPS rig v4 and then it'll download. Next, I'll teach you how to add some other characters. So in the shorts I posted earlier, it's a character from Sprunki, Pinky. However, you can do whatever other character you want. I just thought Pinky was like funny with Steve in it. That's kind of silly. So first, let's see. We're gonna use this thing called mesh.ai. It's free, and basically it can turn 2D images into 3D models, and and you can start for free. It's signed with like an email, I think. And yeah. Next, you just need an image, so you can just go on Google and search up an image, then put it in, and it'll render an image. Alright, so however, I already have my images in, so yeah, I'm gonna put that in. So to put them in, I just use file, append, and I have all of these things. I'm going to, so bps.character.rig is my Steve thing when I downloaded. I click on that, and you click collection, collection, BPS character.rig append. And here you can see this is Steve from the animation studio used by the BPS. You can see it's made of different parts. Those are called bones, I think. If you open this, you can find bones inside, but I'm not gonna do that with this right for now. Yeah, alright. Now let's append in Pinky or whatever you should choose. I'm just recreating the video I did, so that's why. I have to go back to animation. This pink bunny delight thing. But for this one, I think you go to mesh. I think mesh 0. I think. Alright, yes, you can see. Yes, I was right. It's mesh then mesh 0 over here. Alright, you can see I have model here. And Steve, you can do whatever you want with Pinky. Or you can render in whatever you want. Just chose this because, again, it's funny. And that's only good animation. I think there's a way you can make it so that Steve's skin actually looks like Steve. Which is not going to shading. Shading takes too long. You have to do an animation, which I think is viewport shading. Yes, viewport shading. And after a while, you should see the color look more familiar to the characters you know. It might take a while though, so I'll be back when it's done. You can see the color is in, so you can see this is the Pinky, and this is Steve from the Minecraft Animation Studio. It's different from regular Steve. But yeah, it's still kinda Steve. Alright, now let's code animations. So, well, it's a new thing, so let's press new, and then zoom in a bit. And now I can start. So, first things first, importing the things we need. So BPY math. Oh, let's write this again. However, we write it from where? I mean, actually, wait. I have to write this again. Okay. What did I just do? Whatever. It's fine. So, from math utils, import vector. So, now let's first clean up. So what this does is we just make sure everything's clear and ready to go. So we start the stuff for name and fluid domain, water, blob, camera. So those are some things that we have, and we need to clear them, kind of. Objects dot get name if bj if bj data dot objects dot remove obj, and then do only link is true. So kind of infrared thing, like get like the object from this for loop, get a different objects, and then you remove it and then unlink the links for like the nodes and stuff. So over here we just delete these three objects. So, okay, so I explained kind of goofy. So let me explain it. Name. You take these three objects and then delete them under a link, not just like take a name from each of them. Yeah. And now you do it again, but you only delete animation so it can run smoother. Later. BPS character rig obj equals bpy dot data objects dot get name if obj and obj dot animation data obj dot animation data clear. So we clear the animation stuff, so kind of basically like this, except you only delete the animations of both of them. Now we can assign Blender objects. Assign Blender objects. Blender objects to Python. So find Steve. So we just assign some objects in Blender to Python. You just assign objects like from here to things in this Python thing. So let's find Steve. So on Steve here data.objects bps character rig. So arm means armature, and it's just what you call like a bunch of bones, which is what Steve, all these things are called, and they're bones. Model. It's made of things called bones. So yeah. You can find them over here, like I said earlier. Anyways, armature.show in front true. Armature location equals vector 0, 0, 0. So armature, you just like show in front is true. That's like yeah, you just show in front, and then vector 0, 0, 0. So we're just setting up like where they are. Now find Pinky. So the other character, which for me it's Pinky, for you it's any other, the character you chose. So maybe it's called mesh zero data.objects. I think it is for the other characters if you use meshy.ai too. But and vector 4, 0, 0.8. That's the vector. So like where it is, and yeah, you can do wherever you want with it. You can make this wherever you want. because it's your animation. Okay, and then create camera. So we have to add cameras around to like better capture animation. 10, 10, 10, rotation, radiant, 10, 0. So creating cameras is just like making the cameras for our animation. Then math dot radians 10. These 10s, they're just random numbers I put in because we're going to fill them in later. Alright, next bpy.context.scene.camera, bpy.context.active object. Cam is bpy.context.scene.camera. So, context scene camera, it's just giving just saying that it's like an active object and it's a camera, and that's kind of stuff. Ensure consistent rotation mode for O and Linky armature camera. O dot rotation mode is XYZ, not 0 O. So we're just saying that every time it rotates, its rotation is consistently this XYZ. So it's consistent on how it rotates over functions. So this time we're going to make a bunch of define functions to help us animate our animation. The first thing is bone rotation. Def key bone rotation. Name rotation. So key bone rotations, so we can it's going to help us rotate our bones for Steve. First, set pose mode. Context.view view layer object.active equals on. Select set true. bpy.ops.object.mode set mode is pose. So first set the pose mode. So pose is like a mode that we can set this to, where we just kind of tell it make it so that we can move the bone. Wait, no, not like that's not what pose mode does. The pose mode just makes it so that you want to change the pose of the character. Yeah. I confused it too, but pose mode, changing the pose, and now after pose mode, now move the arm. So pb is arm.pose.bones name. One of the parameters, the name, the rotation, and the frame. And PB stands for pose bone. Now rotation mode is XYZ. Beta rotation Euler equals rotation over here, so how much it rotates the rotation mode XYZ over here, P beta armature post bones, and then P dot keyframe insert rotation Euler frame equals frame. So to recap, PP is the arm post bones, and the name is just to help us like get this bone we need. And yeah. And now go back to object mode. Because now that we're done with the rotation, go back to object mode. Mode is object. Alright, now for a second function is bone scale. Def key bone scale, which is what it sounds like, just scaling the bone. Making them like just scaling them. Changing the size of the bone we selected. So yeah, easy stuff. First set to pose mode, like always. And I think we can copy and paste it. Let's try to copy and paste it. Now move. And then that pose that bones. Get the bone from the name. Scale. The scale we scale it is scale. And back to object mode. UI dot ops dot object dot mode set mode equals object. So yeah, same thing as this, but instead in this part we just tell it how much to like scale it by, because in case in the animation you want to like make your animation bones bigger or smaller. So yeah, it allows you to do more stuff. I can move the bone's location, and it's just the same. The key bone lock, short for location. Bone name first set pose mode. Like last time, set it to pose mode, and now move. Arm.pose.bones. Bone name, because same as last time, bone name. Location equals vector lock. So vector, the location, and for location we use the vector to determine how we move it, and then back to object mode. We did this a lot so in our previous functions, so yeah. Node is object. Now camera angle. Wait. Wait, that's the vector. Okay, I forgot to insert the keyframes. Keyframe insert data path is location frame is frame. So same thing here for the scale. I forgot to look at pd.keyframe insert data path scale, and then yeah, frame is the frame that we refined. Okay, I forgot to add that. Now I can do the camera angle, which if you remember from some of our previous projects, the function would take we give it one object or target objects, names of target objects, and it'll make it like show the best angle. So position, camera, names of target objects. So we can tell it the position and then the names of the objects we want it to target and choose. Useful for your animation. And dot location for and names of target objects. Minimum C and maximum C. So the minimum and maximum coordinate positions vector min p dot x for p in min p dot y for p in pts min p dot c for p in points. And I forgot the equal sign over here, so I'm going to add that in. That's a minus sign. Start at the equal sign. Alright. Now same thing for max c, but we replace the min in the vector with max. So x min. Alright. So we determine the minimum maximum location and then send center B. There's min c plus max c times 0.5. Alright, now we're gonna define rotation camera, which I think should give us a rotation. Yeah, it says center B minus the position of the camera. That's 2 track word negative z negative not negative y dot 2 Euler. So this BTS, we take the name of target locations and we'll make a list of tuples, and then the rotation camera will just 2-track port to get like the locations to determine like the best location and to capture the things based on the names in the list of tuples we created over here. So return the rotation camera Now, camera, not angle animation. So, define the camera, so I want it to be like smoothing move and not like just, actually no, that's not what it is. Well, you'll see when I create it. So, for F, P, R, and keyframe. So frames, position, rotation. Cam dot location. The location is position. Rotation is the location. Then keyframe insert. Location. Frame is frame. Okay, well, it looks like I was actually right the first time. This is just animating the camera moving because you have the P in the rotation in this for loop. So the for loop spins and constantly changes this the position rotation of it. So like it just moves according to the FPL of the for loop. And then dot keyframe, and then we can determine the keyframes where it does it in the frame. Yeah, so I was right. Okay, now let's start with the animations. Okay, so I'm going to animate the video, the shorts I posted. So turn starts 30, turn and 60. So these are just variables that will help me with this, the animation I'll be animating later. I mean, right now. So this animation is going to be of turning. If so, you can watching me code my animations. You can learn and code your own animations. So I'm now gonna code facing forward. Both of my characters facing forward. And key O dot rotation Euler equals 0, 0, 0. O dot keyframe insert rotation Euler frame is equal to turn start. So these are actually the frames. So this is the first animation, so we gotta call an animation. So yeah. So that's how you have them both face forward. For Owen, both of these characters, their rotation was going to be 0, 0, 0, so they're all gonna have this rotation Euler. They face forward. Okay. And if you see my video, you can see that I turn Pinky negative 90 degrees and Steve turns positive 90 degrees. So now I'm gonna animate them rotating. So you can watch this and rotate your characters in animation. Rotation Euler. So basically here is how you do it. So you have the degrees, and if you want to have a negative, just put this negative, and then after that you put in the keyframe. So frame is turn end. So frame 60 is when that happens. Actually, Steve is the same thing, so armature. However, I just removed this negative sign in front of this thing and replace pinky with arm for armature. So now they're turning and facing each other at the same time. Okay. Now for the next animation. Animation 2. I'm gonna animate them jumping. So you can also learn how to manipulate their locations. Watching me do it the same. So jump, step equals 6. So actually, for here, I'm gonna ask as manipulate their motions, but also coding something so that they jump, so that they like jump consistently on time. I guess those things. Anyways, jump times equals 240 jump step, and you'll see what I mean later. Base pinky.location.copy pinky.keyframe insert location frame is equal to jump start. So pinky.keyframe insert the location frame equals jump start. So I'm going to manipulate the location by defining this in base the location copy so that it jumps consistently. Then jump position x is a list 0.5 and 0.5. So this way I'll make it so that pinky jumps from side to side. If you want her to jump forward or backwards, it's either X or Y depending on which way you look. Since earlier over here we animated them turning, they're gonna be facing I think this way, so from side to side would be the X part. However, when you animate yours, it could be different. Like it could be Y, it could be X. Now for I in range jump times for my jump times it's 240 slash jump step. So you divide 240 by jump step without the remainder, so the newest integer, so, which is going to make a lot of things easier when you do so position index I modulus 2. And what this does is that it creates a pattern of zeros and ones, 0, 1, 0, 1, because if you do math, yeah, modulus justifies this by 2 and gives the remainder, by the way. So for first time, I is equal to 0, I think. So 0, 2, 0, then 1, it's 1 remainder 1, and then 2 modulus 2 is 0, then 3 is 2 remainder 1, so it's a 1. Alright, and now position x equals jump position x position index. So, remember this jump position X thing over here? We use this position index, then we slap this position index behind this so that there's a pattern between 0.5, negative 0.5, 0.5, negative 0.5. Now we can key that location, manipulate the location is equal to base plus vector position x 0.0 and then 0.4, which is z, so it jumps 0.4 up, which you can see it's easily changeable. Keyframe, insert, location, frame equals jump start plus I times jump step. So we enter the location, and you can see the keyframe is kind of your jump start plus I times jump step. And if you do math, you can see that. I'll comment in the thing. So jump start is 1, so 1 plus 0 times jump step. So first it's 1, then it's 1 times jump step plus jump start, which is 7, because 1 times 6 is 6 plus, and then 2 times 6 is 12 plus 1 is 13. Alright, so this keyframe is every 6 frames it's up. And also base is the one picking is on the ground. So the location when it's on the ground, you can copy this, except we can slap a +3 at the end of the frame. So it's on the ground 4, 10, 16, 22. 4 times 16, 22. It's jumping and lands, and it takes 3 frames for them to do that. And that's it for today. Next lesson we're gonna continue on and finish the animation, putting my animation if you didn't copy it. And I'll show you more things you can do with this while making the animation. But that's it for today. Bye.